girls, here we go with instruction on how to divide square roots. So the quotient rule for square roots is very similar to the product rule for square roots, and you can see that right here. I'll do a little pink highlight right here. And it just says that the square root of a over b, which I'm just writing what you see right there beside, is equal to the square root of a over the square root of b, which is going to give us power when we have perfect squares in the denominator. We'll come back and revisit this in 8.4, but for right now, I want you to watch what happens. So if I want to know the square root of 4 over 9, again, I'm not going to write down every single perfect square, but look, if this is equal to the square root of 4 over the square root of 9, we know that the square root of 4 is perfect, so it's 2, and the square root of 9 is 3. So the square root of 4/9 is equal to 2/3. Sometimes, if we look, I'm going to erase this to clean things up a little bit. Whoops. If you look here at example B, we have the square root of 55 over the square root of 121. If you think through, this should be ringing a little bell right here, that this right here is perfect. So if we know that the square root of 53 over 121 is equal to the square root of 53 over the square root of 121, then I could go ahead and simplify the square root of 121. So that's going to equal, which is 11, the square root of 53 over 11. And there is a rule, and we'll talk about this more in 8.4, that says we can never, never, never leave a radical in a denominator. So the beautiful thing about every example that we've done so far is the denominator is perfect. So again, looking at the square root of 108 over 25, if that's by the product, by the quotient rule equal to the square root of 108, I'm doing C here, over the square root of 25, I know the square root of 25 is 5, and then I've got the square root of 108. But hold on. Is the square root of 108 simplified? And this is when we either need to use the prime factorization or think perfect numbers. Is there a perfect number that will go into 108? Let's see. I'm thinking maybe 4. Let's see if 4 will go into it. 4 goes into twice, whoops, which is 8, then 28, so that's a 27. Ooh, so I know that 108 is equal to the square root of 4 times the square root of 27 over 5. Simplifying, 4 is perfect, so that becomes 2 times radical 27 over 5. You always need to keep asking yourselves, though, is there anything else perfect that will come out of 27? And hopefully you're getting skilled enough at this point that you can say, yes, there still is a 9 that will come out of that 27. So this equals 2 times the radical 9 times 3 over 5. Well, 9 is perfect, so it comes out of the radical and becomes a 3. You multiply by that 2 outside, so this becomes 6 radical 3 over 5. Whew, that was a lot of work, but that's how we just keep simplifying and simplifying until it's as simple as we can possibly get. And so that's C. Let's keep looking though. Let's look at what happens if I put variables in the mix of this quotient rule for square roots. So let me clean things up for us. And here we go. Looking at this example here, the square root of 44 x to the third over 81x. Well, the first thing I want you to notice is, well, let's go ahead and use our, we can see that 81 is perfect. So that's about to happen. What's about to happen is we're about to get that out from underneath the radical. What I also want you to see, I need to clear this, is we could simplify this x to the third over x. Going back to when we divided like bases, remember how we would ask ourselves, how many x's can I cross off and where would the extra ones be left? Well, x to the third over x is actually x squared, because I could cross off 1, and then I have this 44, and then I have this 81 down here. Whoa, something happened. Let's see, undo. Okay, so I have this 44, and then I still have this 81. So all that I've done so far is simplify that x to the third over x. Well, I know that the 81 outside the radical is a 9, and so that is down here. I also know that this x squared is an x outside of the radical, and so that I have x times the square root of 44 over 9. My goal being, what can I get out from underneath the radical and to make things as simple as possible. So I'm still looking at this, and I want to ask myself, am I totally done? Can I simplify 44 anymore? And the answer is yes. There is something still I can do. What perfect square will go into 44? Yes, you are correct. That is 4. So this is x times the square root of 4 times 11 over 9. Well, 4, when it comes outside, it gets a name change. It becomes square root of 4 on the outside is a 2. There already is an x out there, so that becomes 2x radical 11 over 9. And that is the simple as possible. I encourage you to go to your textbook and look at the examples in this. This is 8.2 in your textbook, the very, very end of it. Look at their examples, watch their videos if you need more support than this, or come see me during our Zoom session or schedule one with me so that we can nail this. I hope this helped.